Welcome. This is a very short video on calculating beta 1 in multiple linear regression and what does this mean and what is Frisch Waugh Theorem. So it's a very brief video. What is Frisch Waugh Theorem? I'll try to explain. What is meaning of holding other variables constant, or you may say what is meaning of partialing out, netting out the effect of other variables, and we'll also consider student-teacher ratio data, which we have been discussing throughout our videos, and we'll try to understand this concept in practice. So, what is Frisch Waugh Theorem? Frisch Waugh Theorem is that if you have a regression model, y beta naught beta 1 x1, so first of all regress x1 on x2 xk. Take the residuals. So what does this mean? That effect of x2 xk will be taken away from x1. Residuals will not have x2 xk impact on x1, because we have mentioned that there should be moderate level of correlation between x1 x2 xk. There should not be high correlation between these variables, are perfect correlations. Otherwise, because if they have very high correlation, if this is x1 and this is x2, so it means eliminating x2 basically means eliminating x1. That's why we say that they should not be high correlation, but there must be some correlation that we have studied. Otherwise there will be omitted variable bias. But at the moment I'm going to explain Frisch Waugh Theorem. Regress x1 x2, so effect of x2 x will be taken away, and then regress y on x2 xk, effect of x2 xk will be taken away. So now these are the residuals from step 1, these are the residuals in step 2, and now regress these residuals on x tilde. So the coefficient on x tilde will be the same as coefficient beta 1 calculated in multiple linear regression model. That's what I have done in R. We have this data, California school data from Stock and Watson. We have regressed test score on student-teacher ratio, English learner percentage, expenditure per student, and our coefficient on student-teacher ratio is this one. Now regress this student-teacher ratio variable on these two, take the residuals, and then regress test score on these two variables, test scores on these two variables. So take residuals here, you will get. So we have regression 1 where test score is regressed on English learner percentage, expenditure per student, and y tilde regression, the residuals from this regression. Now student teacher ratio on English learner percentage and expenditure student, and take the residuals. Now regress these residuals on these residuals, so you will get the same coefficient as x tilde, and that I am going to show you that when we have regressed test score on student teacher ratio, English learner percentage, expenditure per student, x tilde, so you have minus 0.286, and when we have done it this way, it is minus 0.286. So please keep it in mind that when we say that this is effect of student teacher ratio holding the effect of these variables constant, it means their effect is partialed out, netted out, taken away from both y and x variable. So that is Frisch Waugh Theorem. Those who want to stop here, they can stop. Those who are interested how to do it in R, be with me. I am going to do it in R. So here we have regression model, and I have uploaded California school data. So we have I need a library Excel, library read Excel. Okay, data. Now we have regressed, and if you want to see this regression output, so you see this is minus 0.286 is the coefficient of student teacher ratio. Now we regress test score on English learner percentage, and we take the residuals, regress x1 and x2, we take the residuals, and then regress y tilde on and you will have minus 0.286, the same coefficient, Stargazer library, and we can have in tabular form. So if you look here, this is test score, and you have same coefficient here, you have same coefficient here. Those who want to stop here, they can stop. Those who want to do it in STATA, be with me. So here we have California school data, and we keep only variables test score, student teacher ratio, English learner percent, expenditure per student. So all other variables are dropped from here. So now we regress test score on student teacher ratio, expenditure per student, and English learner percentage. So let's keep this variable at the end. Now you have coefficient minus 0.286. Now we regress student teacher ratio on the other two variables, and we get predict residuals. We name it resid1 residuals, so we get residuals variables. Now regress test score other than student teacher ratio, take residuals resid2. Now regress resid2 on resid1, you will have the same coefficient as minus 0.286. So this is what is meaning by Frisch Waugh theorem, or holding the effect of other variables constant. That is, we partial out, we net out the effect of other variables when we interpret, when we calculate this multiple linear regression coefficient. So I hope now when you will have this whole multiple linear regression model, you will have a better idea what is meaning of holding other variables constant, or how this coefficient is calculated. Thank you for watching. Take care.